Hi learners, welcome to the subject data mining. Our today's topic is mining time series data. So here I am covering the topics are what is time series, categories of time series moments, trend discovery in time series data, similarity search in time series analysis, data transformation, multidimensional indexing in time series data, steps to perform a similarity search, query languages for time sequences, and examples. Let's get started. So first question is what is time series? What are time series data? So the time series is a collection of observation made sequentially in time. So this is a figure. In this we can see here are the some trends. These are the some trends, that is nothing but the time data, sequential time data. So a time series data is a collection of observations made sequentially within the time. So here are some values given here. According to that, these are the trends has been plotted. These are the trends has been plotted. Here is x-axis, here is y-axis. So we can see here 25.1750. So here, from here it is started, right? After 25.2250, here, somewhere here. So like this, the graph is increasing, about decreasing also, then increased, decreased, like that. So this is the sequential representation of a graph, and the time series graph is nothing but the sequential form of series, right? So here all the similarity measurements, indexing and dimensionality reduction techniques will be discussed by the me with the other data types. What is time series? A time series can be illustrated as a time series graph, right, which describes a point moving with passage of time. So in the earlier slide we have seen the same graph. On this the some of the points were moving like this, and like this. So that is a point moving with the passage of time. So that was nothing but the trend of a time series data. Time series database consists of sequences of value, or we can say events changing within the time, changes with the time, right? Data is stored, that is recorded at the regular intervals. So in the earlier example, the points were written over, that was in the regular nature. So there were the intervals of regular we can see time, right? So data will be recorded and stored in the regular intervals. The characteristic time series components will be the trend, cycle, seasonal, irregular. So these are the time series components, characteristics. For time series data, what are the applications in what are the applications we are using the time series data? First, in the financial type of data. In the financial data, we are having the stock price, inflation, that is increasing and sometimes decreasing. So there have been some regular interval, so that comes under the time series data. In industry, like we are having the power consumption, so some of the time the power is consumption is less, some of the point power consumption is high, so that will also comes under the time series data. Scientific application, like if they are having the experimental results that is recorded for the some of the time series, so that is also comes under the time series data. Meteorological, so like in this we are having the for example, if we are having the precipitation data, So that will also comes under the time series data, because that is having the time intervals. So these were the some applications where we are using the time series data. For example, why we are working with the time series difficult? Why is working with time series is so difficult? So how do we work with the very large databases? So for example, in week 1, R of EKG data, that is 1 gigabyte. For example, if there is a weblog, typical weblog data, that is about 5 gigabyte per week, that is generating 5 gigabyte per week data. A space shuttle database, that is also creating the 158 gigabyte and then growing and growing. So mature database data, that is having the 2 terabyte and updated with 3 gigabyte per day. So these were the large data set where the continuous database increasing and increasing. So since most of the data lies on the disk or tape, we need to represent of the data we can efficiently manipulate. So we can say we have to save the data on the either a hard disk or either a tape. So we need a representation of the same data we can efficiently manipulate. So we need some type of sample data for that, and then we will going to manipulate and represent in the form of how we need that data. So here also the if we are dealing with the subjective notations of similarity, here in the figure we can see here in the first graph, in the second graph, if we are having the two types of time series data, time series trends. So here the definition of similarity depends on the user. So in this we can say here the representation of the data, that is the brown line is there, the dark yellow line is there, blue line is there, straight line and yellow line is there to represent the time series of the sum on the related to the sum of the field. And also in this the similarity is there. If we will see both of the graphs, so some of the similarity exists there. So basically that is only depend on the user, how the user is going to use that data according to, because that was the same data, but according to the user, how he is going to use the data, the representation of the graph, the representation of the time series trend will be different. So that is only depend on the user. So the domain and the task will be at hand. We need to be able to handle this subjectivity. So that is nothing that matters. That matters the how we are going to use the data, particular data. So either it can be same data. Categories of time series movements. So categories of time series movements are long-term or trend movements. What is this? If we are having the trend curve, if we are having the long-term curves, so that comes under the time series movement. So that is the first variation of that. So in that, general direction in which a time series is moving over a long interval of time. Here, as name suggests, that is long term. So there will be long-term interval will be there in the trend, right? So in the second moment, time series moment category, the cyclic moments, or we can say cyclic variations will be there. So long-term oscillations about the trend line occur. For example, if we are having the business data, in that business cycles may be or may not be periodic. So it will be based on the if it is having the quadrant, if it is having the 6 monthly, if it is having the yearly, so that will depend on the business user. So that can be periodic, or sometimes that cannot be periodic, but the cyclic moments and cyclic variance will be the long term. So that will also based on the long term interval. Seasonal movements are seasonal variations. So in that, almost identical patterns that time series appears to follow during the corresponding months of successive years. So here we can say the seasonal moments that comes under the some of the corresponding months at a successive years. So that type of identical pattern will be shown in the seasonal movements and seasonal variations. Irregular are random movements. So if we are having the irregular type of graph, if we are having the random movement type of trends, so that will comes under the category of time series movement. So these were the 4 type of categories of time series movement. How we are going to analyze that time series? So decomposition of a time series into these 4 basic movements. What are they? First is additive model. Additive model. In that, TS time series will be T plus C plus S plus I. T plus C plus S plus I. That is that is trend movement, that is cyclic, that is seasonal, that is irregular. So like this, we have to calculate the time series for that. For the multiplicative model, we have the formula is TS is equal to T into C into S into I. So like that, we need to calculate the time series from the formula. So this is the analysis of time series data. Trend discovery in time series. So here, if we are having the seasonal index, right? If we are having the seasonal trends, so what we will do for the getting the trend, we need to set a number showing the relative value of a variable during the months of the year. What it means? The set of numbers that is showing the relative values of a variable. So the values will be relative, very relative to the other value, while we are having the a set of many values, right? So that can be the a year of a month, or many months. So for example, if the sales during the October, November and December, this is having the sales data. In that are 80%, 120% and 140% of the average monthly sales for the whole of the year. So respectively, then 80, 20 and 140 are seasonal index number for these months. So like this, we need to make the seasonal index of each of the percentage or each of the duration to set the trend of the seasonal data. So we will here in this example, we are making the 80, 20 and 140 are the seasonal index, because there were the sales during the 80 in the October, November and December as 80%, 120% and 140%. So for example, we can understand what the seasonal index means. Next is deseasonalized data. What is this? What it means? Data that is adjusted for the seasonal variations, right? So seasonal variations. If we are having the months, so there will be variations of that for the better trend and cyclic analysis, right? In the deseasonalized data. So here we need to divide the original monthly data by the seasonal index. So how we will get the seasonal index? According to the data which is having the, in the earlier example we have seen they were having the variations of the seasonal months variety. So from there we need to take the seasonal index and then we will divide the original monthly data by the index of the seasonal index numbers, right? Seasonal index numbers for the corresponding month, for which month we need to like for the October we are having the 80 seasonal index, so we need to divide the original data by that, right? So like this we will do the deseasonalized data analysis, trend discovery. Next is estimation of cyclic variations. Cyclic variations, right? So as name suggests, cyclic, so there will be cyclic variations in the trend. So if we can say the approximate periodicity, if there is periodicity of cycles exists or occurs, the cyclic index can be constructed in much of the same manner as seasonal index, right? So as we have seen how we are taking the seasonal index, that is according to the months that is occurred in a year, right? So here also we need to take the cyclic variation, cyclic index according to the periodicity of cycle which exists in a certain period. So we will take the cyclic index and then we need to divide by the original, the cyclic index. Then we will get the actual trend for the same of the time, right? Next is estimation of irregular variations. Irregular variations. So here comes irregular. If we are having the irregular like this, if we are having like see, if there is no trend in between, again like this, that is the irregular interval. So there can be many type of irregular trends. So for that we need to adjust the data for the trend, seasonal and cyclic variations. So we need to adjust the data for all the trend, for the seasons, for the cyclic variations. So after that, with the systematic analysis of the trend, cyclic, season and irregular components, it is possible to make a long or short-term prediction with the reasonable quality. So these were the 4 type of trend discovery in the time series. And after that we need to combine them, and we will able to predict about the we will need to predict about the semantic analysis. We will get the possible long term prediction, long or short term prediction with the reasonable quality. So there will be quality if we are working on the 4 of the aspects of the time series data, right? So in this we have covered the 4 type of trends, right? Similarity search in time series analysis. That is, normal database query finds exact match, right? If we are searching for the similarity and in the time series, so what will be the normal database query? That is always finding the exact match, right? But similarity search finds the data sequences. In the similarity search, we will find the data sequences that will differ only slightly from the given query sequence in the similarity search of time series analysis, right? 2 categories of similarity queries we will use. First is whole matching, second is subsequence matching. Whole matching means that, as name suggests, we need to find a sequence that is similar to the query sequence. So whole of the sequence we need to match with the query sequence, right? So we need to write the query that is having the same of the sequence for the similarity matching, similarity searching. So second is subsequence matching. In this we need to find all of the pairs of similar sequences, right? Similar sequence. So we need to find the pairs of similar sequences here in the subsequence matches, right? So the typical applications are, as we have seen in earlier slides, there are financial market, right? While we are having the similarity matches, similarity search. So we can see this in the financial market basket data analysis, scientific databases and medical diagnosis data types. So this is the example of time series. Here time series similarity, some of the time series is there. Here we are having the classification time series, okay? Here we are having the clustering of the time series, right? we can understand now this is the clustering. This is the dendrogram actually. So here the sum of the cluster has been made of the trains. So these are the 4 trains. The cluster of that has been made. That is classification. How? Because we are having the some type of regular and irregular. Some of the trends are high at peak and some of the trends at low peak. So this is the classification of the trend. Here we are having this rule discovery. In that we are having the 2 types of time series data, right? 3 types of time series data. So while we are using this and this, we are getting this like this. So this is the rule made for the this trend, right? Query by content. So here query queue, that is a method. Here we need to query queue template and we will get the this database C. For this we will get the result in the database C. So these are the trends we can see in the example. So the defining the similarity between the 2 time series is at the heart of the most time series data mining and applications and tasks, right? So every time we need to define the similarity for the time series data, for the 2 time series of data, and that will be using by the many applications, right? So thus time series similarity will be the primary focus of we are having in this tutorial, in this lecture. Data transformation. So here also we need to do the data transformation, right? So many techniques for signal analysis require the data to be in the frequency domain. So what is frequency here, right? So for any of the trend, right? If we are having any trend like this, so this is the frequency of the data. This is the frequency of the data. So with the regular interval, the frequency, the trend is going on. So that is the frequency of the data. So for the many techniques for signal analysis require the data to be in the frequency domain. Usually data independent transformation are used. The transformation matrix is determined a priori, that is discrete Fourier transform. That is a method to find the transformation matrix. Second is discrete wavelet transformation, DWT. So these are the 2 techniques while finding the transformation matrix. Also the distance between the 2 signals, right? Distance between the 2 signals in the time domain is the same as their Euclidean distance. So in while we are doing the data transformation, we need to calculate the distance between the 2. So for the 2 signals, there will be the distance between the 2 signals will be the time domain of their Euclidean distance, also in the frequency domain. So this was the transformation of the time series data. So what is discrete Fourier transform? So here is the formula to calculate the discrete Fourier transform. So this is first, in the first formula we are having the x of k is equal to summation of n minus 1 to n is equal to 1 x n e to the power minus 2 pi I k n divided by capital N, right? So this is for the even type of data. So here in the next example we are having the x n is equal to 1 upon n summation of n minus 1 to k is equal to 0 x k e to the power 2 pi I k n divided by n. So here we have added the 1 upon n. So this is for if we are having the 0 that is less than equal to k, that is less than equal to capital N minus 1. So here for the discrete Fourier transform, that does a good job of concentrating energy in the first of the few coefficient, right? So these are the coefficient here. So here if we will calculate the we will calculate the Fourier transform for that. So we will get the concentration energy for the few of the coefficient. If we keep only first few coefficient in DFT, that is discrete Fourier transform, we can compute the lower bounds. We can compute the lower bounds of the actual distance, right? And that we need to feature extract. For that, we need to keep the first few coefficients, right, f index, as representative of the sequence. So this was all about the discrete Fourier transform method, right? So there is also one method that is Parseval theorem. So on that also we can also use the to calculate the discrete Fourier transform. The Euclidean distance between the two signals in the time domain is the same as their distance in the frequency domain, as we have seen in the earlier example. So for that, we need to keep the first few. If we can say, if we are keeping the 3 of the coefficient underestimates the distance. So there will be no false dismissals. So this is the formula to calculate that. Multidimensional indexing in time series. Multidimensional index. So multidimensional construction, in that we need to construct for efficient accessing using the first few Fourier coefficient, as we have found from the formula DFT, right? So we need to use the first few Fourier coefficient to construct the multidimensional index, right? After that, we need to similarity search. We need to do a similarity search. So for that, we need to use the index to retrieve the sequences that are at very, very most certain small distance away from the query sequence. Secondly, we need to perform a post-processing by computing the actual distance between sequences in the time domain, right? In the time domain, and that will be discarded by the false matches. If there will be no matches, that will be discarded. Otherwise, it will be accepted. So we will do the post-processing by computing the actual distance. Subsequence matching. So there were also a technique to calculate to process the time series. So in subsequence matching, we need to break each sequence into a set of pieces of window with length W. So here we can see in the figure, we are having some trend like this, like this, like this, like this. Right? This is the trend. Right? So what is subsequence matching? So here we will need to take a set of pieces. Here we have taken this piece, then this piece, like this. I'll show here. Like this, like this, like this. We are having some trend, right? We are having some trend. If we are taking this part, right? This part. Somewhere we are taking this part. Somewhere we are taking this part. Somewhere we are taking this part. Like this, we need to take a set of pieces of that trend, right? We need to take a subset. So we need to break each sequence into a set of pieces of window with the length W. So total length of the trend is calling as a W. Then after that, we need to extract the feature of the subsequence inside the window, right? So after that, we need to map each of the sequence to a trail in the feature space. That is, the next step is divide all the trail of each sequence into sub trail, right? When we will take the trail, and then after we will take the sub trail. So and then we'll need to represent each of them with the minimum bounding rectangle. So the sub trails is nothing but this boundary. So that is calling as a sub trail. If we will take a one whole trail, that we call as a trail. So we need to get the minimum bounding rectangle from that. Then we use a multi-piece assembly algorithm. That is an algorithm where we are having the multi pieces of trend. We are having a set of pieces of some of the trend. So we need to apply this algorithm to search for the longer sequence matches. Where is the longer sequence is occurring. So like this, we need to do the subsequence subsetting, subsequence matching. Yes. In this example, that is the analysis of some time series data, right? So here we are having the 5 types of five types of analysis of time series data. So in the first example, we can see the original sequence, right? Original sequence. So here, some of the trend is like that is there, and we are after the analyzing the same of the sequence, we are getting the this type of trend. In second of the example, we are removing the gap. So here, what we can see here, the trend is there, but here is we need to remove the gap. This gap we need to remove. So we will start this from here. So after applying some of the methods, we are getting these type of time series data, time series trend. In the third example, offset translation is there. In the fourth, amplitude scaling is occurring. In the fifth, subsequence matching. So we have already taken the method of that, how the subsequence matches is going on. So these were the analysis pictures of the analysis graph of the similar time series data. Enhanced similarity search methods. So some of the advanced search methods are also there for the similarity search. In that we need to allow for gaps with the sequence or differences in offset, we can say amplitude, right? So this is the first step. Second, normalized sequence with amplitude scaling and offset translation. Two subsequences are considered similar if one lies within one envelope of epsilon width around the other. That is ignoring outliers, right? So that is another type of method. Another method is two sequences are said to be similar if they have the enough non-overlapping time-ordered pairs of a similar subsequence. So they will call as a similar when we have the same of the property. So in the next, if we are having the parameters specified by the user, we can say expert, domain expert. So here we are having the sliding window size, width of an envelope for similarity, maximum gap, and matching fraction. So these are some methods to enhance the similarity search. Steps to perform a similarity search. So the first is atomic matching. In atomic matching, we need to find all pairs, right? All pairs of what? Gap-free window. Gap-free window of small length. That is very, very similar to each other. So that is the atomic matching we are searching, right? In next, we need to window stitching. Second is window stitching. In this, we need to stitch other similar windows to form a pair of large similar window. Or we can say subsequences. That is allowing gaps between the atomic matches. So here the gap is allowed between the two of the matches. Next is subsequence ordering. In that linearly order the subsequence, we need to order the linearly the subsequence matches. For that we need to get the enough similar pieces that is existing or not. So we need to search for that. If the similar pieces are existing, we need to match with the subsequence match. Similar time series analysis. So in this example, there are some, this is when if international fund series data, here fidelity, selective precious metal and mineral fund time series data. So in these two graphs, we can see we are having some of the price and time related map trend, right? So here we can see these are some similar type of trends that is matching with each of that, right? So that is looks similar in some of the parts, right? So two of the similar mutual fund in the different fund group. So this is the time series, similar time series analysis we can apply on that. Query language for time sequence. Query language we are using for time sequence. So that is another method while we are using the time series sequences. So time sequence query language that should be able to specify sophisticated query. So in the traditional database we need to write the query for to fetch the sum of the data set, some of the data from the table, right? So here in the for the time series data, for the data mining, we need while we are doing the time series analysis, we need to write the time series query language. So we should be while we are using writing that, we will be able to specify sophisticated queries. That is, we need to find the all sequence that are similar to the sum of the sequence in class A, but not similar to the any sequence in class B, right? So this is the some example. Then we should be able to support various type of queries like range query, right? There will be range query, all pair query, and nearest neighbor query. So we need to write the query like then we will query for the time sequence. Then we will able to support the various other type of query languages also. The shape definition language. There is also the query language shape definition. In that we allow user to define and query the overall shape of time sequence. So that is another method where we are defining and writing the query to get the overall shape of the time sequence, right? Then we uses the human readable series of sequence transition, we can say macro. So that is calling as a macro. So the sequence transitions that is recorded as a macro, we need to use for the human readable series of sequence transitions. Ignore the specific details we need to ignore. So for example, if we are having the pattern small up, capital U and P up, and capital UP like up, that is a query language written over somewhere. So we can be used to describe increasing degrees of rising slope. So here we need to ignore these type of specific details, right? So here are the some matches, but that is written like a human readable series, right? Like micro, we are having a spike, valley, etc. So we need to remove the specific details of the some of the series, some of the sequence. So that was all about the time series data. We have covered all of the aspects of time series, the methods, what are the analysis methods we are going to use, what is the methodology, what are the different methods we can use to fetching while we are going to analyze the time series data. So that was all about the time series data sequence. So thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.